deep beneath our feet, buried in rock strata. 65-million-year-old scientists uncovered something that should not have existed: microscopic spheres of rare metals dispersed throughout the planet in a way that is identical to what we observe in modern nuclear testing. But these worries predate human civilization by an insurmountable amount. We have always believed that we were the first species to split atoms, melt metals, burn fossil fuels, and alter our planet's atmosphere. But what if we're wrong? What if Earth has already supported intelligent civilizations, and geological time has eradicated all evidence of their existence? Today, we will look at evidence that challenges all we thought we understood about our planet's history. We'll look into lost nuclear signals, strange major extinctions, and why the fossil record has such massive gaps. Prepare yourselves, we begin. In 1980, geologist Walter Alvarez was studying geological layers in Italy when he discovered something extraordinary. A small clay band separating the Cretaceous and Paleogene periods contains 30 times more iridium than typical. This uncommon metal is prevalent in asteroids but nearly lacking in the Earth's crust. The discovery fundamentally altered our understanding of major extinctions. That iridium surge became evidence of the asteroid strike that killed the dinosaurs 65 million years ago. But what struck scientists the most was how vividly this single cataclysmic event left its mark on the geological record. This discovery, the spark. The worrying question is, if one asteroid hit can leave such evident evidence 65 million years later, what signatures will a sophisticated technological society leave behind? Most importantly, would we recognize them? This way of thinking gave rise to the Silurian Hypothesis, named after an old species described by Dr. This scientific idea questions whether industrial civilizations could have existed on Earth long before humans, leaving behind signs that have been so subtle or changed by geological time that we have yet to discover them. Consider the magnitude of deep time. If human industrial civilization lasted 10,000 years and then perished, it would be just 0.2% of Earth's 4.5 billion year history. Finding proof of such a tiny period would be like to searching for a single page in a library with 4 million books. However, evidence should exist. Every industrial society must use energy, change atmospheric chemistry, and generate waste products that last much longer than structures or machinery. These traces become part of the Earth's everlasting geological record, preserved in rock layers, ice cores, and sedimentary deposits. The difficulty is in recognizing these signals. We know what modern industrial activity looks like because we're building it right now. We emit carbon dioxide into the atmosphere, spread plastic particles over the world, and create radioactive isotopes that will last for thousands of years. Future geologists would easily recognize human imprint on the globe. But what about prior civilizations? Use various technologies. What if they harnessed energy? We have not discovered or manufactured materials that degrade differently than our plastics and concrete. Their industrial signatures could be hidden in plain sight and mistaken as natural events. The iridium layer demonstrates that Earth keeps traces of significant events over long periods of time. If the planet can keep track of a single day when an asteroid struck, it should be able to preserve remnants of civilizations that may have lived for millennia. Scientists began to examine the geological record with fresh eyes, looking for patterns that could suggest past industrial activity. What they discovered, challenges, are the most basic assumptions about life on Earth. The proof begins with a conundrum hidden in the Earth's fossil record. The fossil record on Earth should provide a complete picture of life on our planet. Instead, it reads like a book with the majority of its pages pulled out, leaving only shards that hint at chapters we can't read. Paleontologists refer to these missing parts as gaps, although that term fails to convey their amazing extent. Complex life forms occur suddenly in the fossil record during the Cambrian explosion 540 million years ago, as if someone flipped a switch before to the event. Following that, we find largely basic, single-celled creatures. The water is teeming with animals with eyes, shells, and complex body layouts. This transition should have occurred over millions of years of slow evolution. It appears to have occurred practically quickly. Geologically, the fossil record provides no explanation for this sudden increase in complexity. But the Cambrian explosion is only one of several inexplicable gaps. The fossil record shows several periods in which life appears to advance. Species appear, thrive, and then vanish without explanation. New kinds of life arise fully developed, as if they appeared out of nowhere. Traditional explanations suggest a preservation bias. Soft-bodied species seldom fossilize. Thus, we could be missing an important evolutionary transition. Environmental circumstances influence fossilization rates, resulting in apparent gaps where progressive change has occurred. These variables undoubtedly contribute to the incomplete record. However, certain gaps appear to be too systematic and timed to be the consequence of random preservation failures. They correlate with significant shifts in atmospheric composition. Ocean chemistry and global temperature patterns indicate that something beyond normal evolutionary processes was taking place. Consider the Great Oxygenation Event 2.5 billion years ago. Oxygen levels in the Earth's atmosphere suddenly soared substantially, harming the majority of existing life. While allowing new types of life to evolve, the shift significantly altered the planet's moral, chemistry, and biology. Scientists ascribe this event to cyanobacteria, which began to manufacture oxygen through photosynthesis, although the timing and extent of the transformation appear unusually precise for a natural phenomenon. The increase in oxygen follows a pattern similar to what would occur if an advanced society developed. Atmospheric chemistry is manipulated on a large scale. Similar patterns appear throughout the fossil record, with periods of stability interrupted by sudden dramatic changes that reshape life on Earth. Mass extinctions followed by rapid diversification of new species, and chemical signatures in rock layers indicating massive coordinated alterations to planetary systems. These patterns could be the product of natural processes that we do not completely comprehend. Earth's temperature and chemistry are controlled by complicated feedback loops that can cause abrupt transformations under specific situations, but they can also signal something completely different. What if some of these gaps correspond to periods when prior civilizations ruled the planet? Their industrial operations could have had a significant impact on the environment. That most existing species became extinct, leaving visible gaps in the fossil record. The fast creation of new life forms could indicate either evolutionary reactions to changing environments or genetic manipulation by advanced creatures. Even odd evidence can be found inside the rock layers themselves. Every factory, power plant, each piece of heavy equipment, chemical signatures remain long after the structures themselves dissolve to dust. These marks are absorbed into the Earth's geological record, providing lasting proof of industrial activity that can last for millions of years. Modern manufacturing generates unique isotope ratios that differ significantly from natural processes. When we burn fossil fuels, we liberate carbon that has been stored underground for millions of years. This ancient carbon has a distinct isotopic signature that appears in air measurements and is retained in tree rings, ice cores, and marine sediments. Nuclear weapons testing resulted in radioactive isotopes that appear nowhere. In nature, these manufactured materials will be visible in geological samples for thousands of years, providing future scientists with undeniable evidence that an advanced technological society existed on Earth, 20th and 21st. But here's where the enigma intensifies. Geologists have uncovered similar abnormal isotope fingerprints in rock layers dating back millions of years before human civilization. The Permian Trilogy, the boundary indicating the Big Death 252 million years ago, contains carbon isotope ratios that are identical to those observed during enormous fossil fuel combustion. The size of this signal suggests that an event occurred that released carbon comparable to the combustion of all known coal, oil, and gas reserves. Traditional explanations involve major volcanic eruptions or methane releases from warming waters over relatively brief geological time periods. These natural processes might conceivably give identical carbon signatures, but the precision and timing of the isotope shifts indicate a more systematic occurrence than random geological phenomena. Deep ice cores from Antarctica contain air samples dating back 800,000 years. Within these samples, scientists discovered periods of rapid atmospheric change that are similar to what we could expect from large-scale industrial activities. Concentrations of greenhouse gases surge and then remain elevated for thousands of years, then return to baseline values. These patterns emerge repeatedly throughout the ice core record, always followed by modest changes in atmospheric chemistry, indicating coordinated manipulation of planetary systems. The alterations are far too quick and systematic to be caused by recognized natural processes. Microscopic titanium spheres can be found in Colorado's rock formations. Other rare metals are grouped in strata corresponding to specific time periods. These spheres are identical to particles created by high-temperature industrial operations, although they appear in geological strata formed long before humans discovered metallurgy. Similar metallica abnormalities have been found in sediment cores from deep ocean basins. The metals are dispersed in patterns that indicate widespread atmospheric dispersion, as if they were released by multiple industrial sources working concurrently on different continents. Ocean sediment cores provide further evidence of prehistoric industrial activity. Sediment layers contain high amounts of man-made chemicals that should not exist in nature. Nonetheless, they emerge in geological contexts that precede human chemistry by vast margins. These chemical traces may have natural explanations that we have yet to discover. Earth's geological processes are extremely complex, and we may be misinterpreting signals of exceptional activity. However, natural events are exhibiting patterns that are becoming too numerous and systematic to ignore. The proof extends beyond chemistry to materials that should not exist at all. Plastic will be humanity's most lasting legacy long after our cities have crumbled and our bones become dust. Microscopic plastic particles will remain lodged in sediment layers, presenting future geologists with undeniable proof that an industrial civilization once reigned. Plastic degrades extremely slowly in natural conditions. Even when exposed to sunlight, heat, and chemical weathering, plastic shards can last hundreds or thousands of years. Plastic can remain virtually unaltered in deep ocean sediments or freezing settings for millions of years. Plastic's longevity makes it a suitable geological marker. Future scientists examining the Earth's sediment layers reveals a dramatic transition in which plastic particles appear in massive amounts, signaling the start of what geologists may refer to as the Anthropocene period, the era when humans began changing the world through industrial activities. However, recent discoveries reveal that we are not the first civilization to leave such marks behind. Sediment cores from remote ocean basins contain minuscule particles of what appear to be synthetic polymer molecules in layers generated millions of years before humans invented plastic. These particles have features similar to current plastic pieces, such as resistance to natural degradation processes and chemical compositions that do not occur naturally. The particles appear in discrete layers separated by millions of years, implying that widespread synthetic material synthesis occurred several times before ceasing entirely. The distribution patterns reflect worldwide diffusion, as if these products were manufactured and used by a worldwide civilization. Advanced analysis shows even more perplexing information. Some of these ancient polymer pieces have molecular architectures that improve upon modern plastic technologies. They show evidence of engineering meant to increase longevity and resistance to environmental disintegration, implying that their developers have a thorough understanding of material science. Deep drilling initiatives in Antarctica have yielded ice samples containing identical man-made particles in layers generated hundreds of millions of years prior. The particles are well maintained in the ice, retaining their original molecular structure, while offering unambiguous evidence of their artificial origin. These results call into question what we previously thought we knew about materials science and planetary history. Either natural processes can produce flawless polymer mimics under unknown conditions, or past civilizations created advanced chemistry long before humans arrived on Earth. The time frame implications are startling. If these particles indeed constitute evidence of past industrial activity, technological civilizations have risen and fallen several times throughout Earth's history. Each episode left its mark. Before totally fading, a signature is left in the geological record. Geologists initially found layers of unique mineral deposits in Australian rock formations. A closer look revealed that these minerals were deteriorated, containing shards of synthetic materials with complicated molecular structures that required advanced manufacturing procedures to make. Carbon analysis of organic material discovered among these fragments reveals ages extending back millions of years. However, the synthesized chemicals exhibit no symptoms of breakdown, which should occur over such long time frames. This preservation suggests either unknown natural mechanisms or industrial skills that are far beyond existing human capabilities. The evidence requires us to consider an unpalatable possibility. We may be strolling through the remnants of ancient civilizations without even realizing it. Their greatest technological achievements have been reduced to minuscule particles strewn through sediment levels, misidentified as natural phenomena by experts who believe we were the first. However, the most troubling evidence comes from deep underground, where nuclear signatures reveal an inconceivable story. In 1972, French geologists examining uranium ore from the Oklo mine in Gabon, Africa, made an unexpected finding. The uranium revealed unambiguous evidence of sustained nuclear chain events that happened naturally 2 billion years ago, creating what geologists today refer to as natural nuclear reactors. These ancient reactors ran for hundreds of millions of years, consuming uranium fuel and producing radioactive waste. The discovery demonstrated that nuclear reactions might occur naturally under very particular geological conditions, which scientists had previously thought required sophisticated human technology. However, the Oklo reactors did establish a key principle. Nuclear activity creates distinct marks in the geological record that last billions of years. Isotope ratios produced by nuclear reactions are so different that they can be detected and studied long after the events have stopped. This conclusion prompted scientists to look for other nuclear traces throughout Earth's geological past. What they discovered has significant ramifications for the Silurian theory. Kazakhstan's uranium reserves possess isotope ratios identical to those produced by nuclear weapons testing. The ratios emerge in rock layers generated 50 million years ago. Long before humans invented atomic technology, the signatures were too precise and concentrated to be caused by natural processes like Oklo reactors. Similar weapons-grade radioactive signals have been found in ancient geological strata on 6 continents. The distribution suggests internationally coordinated nuclear weapons testing. However, these markers emerge in rocks that precede human civilization by a large margin. Deep core samples from the Greenland ice sheet include radioactive isotopes that are not found naturally on Earth. These isotopes are only created by certain nuclear processes that need perfect control of neutron flux and temperature conditions. Their presence in ancient ice shows that prior civilizations developed nuclear technology that outperformed modern human capabilities. The isotopes emerge in various layers separated by thousands of years, indicating that advanced nuclear activity occurred multiple times before ceasing entirely. The pattern matches what we may expect. If scientific civilizations gained to prominence, produced nuclear weapons, and then destroyed or perished for various reasons. Ocean sediment cores from the Pacific contain plutonium isotopes in layers that correspond to catastrophic extinction events in the geological record. Plutonium does not occur naturally on Earth and can only be created using advanced nuclear technology. Its presence in ancient sediments shows that nuclear weapons may have played a role in some of the planet's mass extinctions. The abundance of these isotopes is astonishing. Certain geological formations include concentration